Hello, let's continue factoring. We're going to look at factoring trinomials where the leading coefficient is not 1, perfect trinomials, and difference of squares. So we're going to factor trinomials where A is not 1. We're going to do so by grouping. So we're still going to multiply the leading coefficient A and the constant. So we're factoring 2x squared plus 9x plus 4. We're going to multiply 2 times 4, which will give us 8. We're going to look at the factors of 8 and see what will give us a sum of 9. So easily we can see that it's 1 and 8. So we're going to split the 9x to make x and 8x. So we can rewrite the expression. And once we split the expression in half, we're going to factor the GCF out of the left side and the right side. So on the left side, the GCF will be x, which will leave us with 2x plus 1. On the right side, it's going to be 4, which will also leave us with 2x plus 1. Again, by getting that common factor, that tells us we've done something good, so that when we go to write our final answer, we're going to take the outside factor of x, in this case plus 4, bring them together, and keep the common factor. So let's try another together from the top. So we're going to factor 2x squared minus 7x plus 3. We're going to multiply 2 times 3. And get 6. So we want the factors of 6 that will give us a negative 7. So we know both our factors are going to be negative. We'll have negative 1 and negative 6. So we're going to rewrite 2x squared minus 7x plus 3, replacing the negative 7x with minus x with minus 6x plus 3. Now we're going to split. So now that we're made to split, we're going to factor. We have 2x squared minus x. That gives us the GCF of x and leaves us with 2x minus 1. On the right side, we have negative 6x plus 3. So that GCF is going to be negative 3, which will leave us with 2x minus 1. So now, we will write our factors, keeping the common factor, 2x minus 1, and bringing those outside GCFs together to make x minus 3. Take a moment, pause the video, try number 2 on your own, and then restart the video when you're ready. 5 times 12 that would be 60. So we'll multiply to get 60 and add to get 16. And those two factors will be 10x plus 6x plus 12. So we replace the 16x with 10x and 6x. And then we'll split it in half. We got 5x squared plus 10x. So the GCF on this left side will be 5x, leaving us with x plus 2. And on the right side will be positive 6, also leaving us with x plus 2. So again, you see we did something correct. So we will keep the common factor of x plus 2 and bring those outside factors together to give me a factor of 5x plus 6. So let's take a look at our next practice problem. Number 3. Now we have 4 terms. So as always, first thing we should look for is a GCF. So 10x squared minus 25x plus 6x minus 15. Is there a number that goes into 10, negative 25, 6, and negative 15? There's not. So given that we have 4 terms, if we split it in half, we can factor it still by grouping. So 10x squared minus 25x. The GCF on this left side is going to be 5x, leaving us with 2x minus 5. On the right side, that GCF is going to be 3, leaving us with 2x minus 5. So a common factor, which tells me we did something correct. So we're going to keep that common factor of 2x minus 5 and bring those outside factors together to make the binomial 5x plus 3. Take a moment to pause the video, try practice problem 4, and press play when you're ready to continue. So in problem 4, we have 4x squared plus 20x minus 24. Looking for the GCF first. 4, 20, negative 24. They all have a greatest common factor of positive 4. We have x squared x, and with negative 24 being a constant, that only makes 4 our GCF. So we're going to divide each term by 4. And in doing so, we're going to be left with x squared plus 5x minus 6. So if we keep our GCF of 4, now we can try to factor this trinomial of x squared plus 5x minus 6. So is there anything we can multiply to get negative 6 and add to get 5? So we write off factors 6, 1 and 6, 2 and 3. We know 1 would have to be negative, so negative 1, negative 2, or positive 1, negative 6, positive 2, negative 3. We need a sum of positive 5. So we're going to use the combination of negative 1 and positive 6. So we're going to keep the common factor of 4 times x minus 1 and x plus 6. Again, the order in which you write the binomials does not matter. Now let's take a look at our perfect trinomials. Perfect trinomials follow the pattern of a squared plus 2ab plus b squared. So notice your leading coefficient and your constant are both perfect squares. Same thing with a squared minus 2ab plus b squared. Notice the constant is always positive because it is a perfect square. So if we have x squared plus 8x plus 16, we want to multiply to get 16 and add to get 8. That being x plus 4 and x plus 4. Again, which can be written as x plus 4 squared. That's perfect trinomials. So take a moment, pause the video, try problem 2, and press play when you're ready to continue. In problem 2, we want to multiply to get a positive sign and add to get a negative 6. That's going to be x minus 3 times x minus 3, which can be written as x minus 3 squared. So now let's take a look at our difference of squares. So if you have a difference, meaning it's a subtraction symbol in between two squares, it's going to factor to a plus b times a minus b. So first, let's look at it from if we already know the factors and we want the product so that we can see what that'll look like. If we FOIL this, we'll get x squared minus 3x plus 3x minus 9. So combining the terms, negative 3x plus 3x is 0. So our product is going to be x squared minus 9. Notice the middle will cancel out. Same thing if we multiply 2x minus 3 times 2x plus 3. We're going to have 4x squared plus 6x minus 6x minus 9. With, again, our middle terms canceling it out, leaving us with 4x squared minus 9 as the product. So take a moment and factor the following. Pause and then press play when you're ready to continue. Remember, they're going to follow the pattern with a plus b times a minus b. X squared minus 25. What do we square to get 25? It's 5, so that's going to factor into x plus 5 times x minus 5. 9x squared minus 49. So we're looking at what we square to get 49 and what we square to get 9x squared. So the square root of 9 is 3, so it's going to be 3x minus 7 times 3x plus 7. Now, number 3, 4x squared plus 1. That's not a difference of squares, so that is not factorable. Okay? It must be a difference, so you should see a subtraction symbol. And with 4, first thing we have to do is factor GCF, which in this case is going to be negative 1. We want to rewrite this, factoring out the negative 1, as x squared minus 4. We like having a variable term first. Now, we're going to keep that GCF of negative 1 and factor this to x plus 2, x minus 2. Okay. For additional practice problems, I would like for you to refer back to page 221 and do problems 56, 58, and 61.